All right, let's jump right into this explainer. Today, we're neutrally unpacking a really fascinating critique by an author who goes by Ziana Chat. We are looking at a highly detailed argument that suggests, and this is wild, that a fundamental misunderstanding of 3D space might sit right at the very core of Albert Einstein's special relativity. The author's basic premise is that before we even touch complex mathematics or the fabric of space-time, we really have to stop and examine how humans actually perceive the physical space around them. To get into this, think about how a baby sees the world for a second. Early on, infants see everything almost entirely as this 2D pointillism. They're getting visual data, sure, but they totally lack the cognitive concept of depth, distance, or even a path for that light to travel. They just don't know there's an outside spatial reality yet. It's kind of like that famous René Magritte painting, The Key of the Fields. You know, the one where a painted canvas perfectly blends into the landscape behind it. It completely blurs the line between a flat 2D image and actual 3D reality. Basically, if you don't know the depth is there, you literally can't perceive it. We're going to build this argument from the ground up across 5 quick parts. 1. 2D vision and spatial illusions. 2. Constructing the 3D framework. 3. Einstein's missing y-axis. 4. The Pythagorean budget trick. And finally, 5. Returning to the life world. Part 1. 2D vision and spatial illusions. Okay, so the author starts by defining what they call the window surface. Think of this as your pure field of vision, literally just what you see directly in front of you. It's the 2D plane that visual information passes through. Imagine it like a movie screen at the cinema, or maybe a Dürer grid that Renaissance painters used, or honestly, just the pupil of your own eye. It is the flat boundary separating what's inside our vision from the outside world. But then, in stark contrast, we have the floor surface. This is the actual external physical reality where things reside and move. This is the space where a real train is driving, or a physical object is sitting. And the core argument here? The author suggests that confusing that flat 2D window surface with the deep 3D floor surface creates massive cascading errors in how we calculate physics. Part 2. Constructing the 3D framework. To fix that exact confusion, the author constructs an absolute geometric reality of observation, basically a strict map to separate the image from reality. Let's walk through it. Step 1. The information's final destination is your retina, which we'll place at y equals -10. Step 2. The window surface, the pupil, where light passes through, sits right at y equals 0. Step 3. The space extending straight out in front of you is the y-axis. That is your absolute depth. And finally, step 4. The actual physical objects on the floor surface are out there on that y-axis depth, say at y equals 10 or 20. This alignment creates a straight line of physical depth that light literally has to travel across to reach you. Part 3. Einstein's missing y-axis. Now, here is the crucial point. The author applies this strict spatial map to Einstein's famous light clock thought experiment, the one used to formulate time dilation. And the critique argues that Einstein essentially treated moving objects like a 2D projection acting purely on that window surface. According to the author, he completely forgot the y-axis. He analyzed the movement of a photon as an event happening on a flat screen without depth, totally ignoring the absolute distance the light had to cover from the moving object out in the real world back to the observer's retina. And this brilliantly illustrates what the critique calls the orthographic projection trick. By only looking at the window surface, the observer is essentially seeing a flat projection of reality. The author proposes that confusing the physical time it takes for light to travel across that y-axis depth with actual time dilation is the grand illusion right at the heart of relativity. So by ignoring the time it takes for light to cross from the floor surface to the retina, a simple delay in receiving information is mathematically misread as time physically stretching. In the author's view, if you bring back classical Maxwell electromagnetism and just factor in that the light simply took longer to cross that y-axis depth, the paradoxes of relativity vanish. It's just a time delay, not time dilation. Part 4. The Pythagorean budget trick. Let's dive a bit deeper into the specific physics here. How exactly does this mathematical trick play out? The author uses a concept they call the Pythagorean budget allocation. Think of the absolute speed of light, c, like a strict budget. If an object is moving horizontally on the x-axis, the light traveling diagonally from it is eating into the budget for the light coming forward on the y-axis toward you. Because a portion of the speed is consumed by that lateral movement, the forward-moving component gets reduced, which means the light just arrives later. It's a delay. But because Einstein allegedly erased the y-axis from the thought experiment, he misread this delayed arrival as time itself stretching. Summarizing this exact critique of the light clock, we see a whole cascade of alleged errors. It begins by confusing an object's local resting state with absolute zero velocity against the electromagnetic field. From there, the y-axis depth is erased, flattening what should physically be a 3D spherical wave into a simple 2D V-shaped line. And ultimately, it ignores the two-stage delay of information transfer, the reality that light must first travel from background space to the object and then from the object to your eye. Part 5. Returning to the life world. This brings us to the author's philosophical conclusion, which takes a step back from the math to look at how we even do science. To cure this so-called mathematical narrow-mindedness, the author leans heavily on philosopher Edmund Husserl's concept of the life world. The argument is that we absolutely must ground physics in the escapable realities of human observation. Before we build these grand mathematical simulations, we have to acknowledge the absolute physical geometry of how light hits our retinas. We just can't build formulas that ignore the physical reality of human perception. Which leaves us with a massive, provocative question to ponder. If the world's most famous physics equation missed a fundamental spatial access simply because we struggle to separate a 2D image from 3D reality, what else in our universe might we be seeing only in 2D? That's what this explainer leaves us with today. Keep questioning the framework.